Hello, I'm going to talk today about the Chebyshevs theorem and the empirical rule. This will help you with your assignment um, in my stat lab. So let's consider a population of 1,024 mutual funds that primarily invest in large companies. You have determined that mu, the mean 1-year total percentage return achieved by all funds, is 8.2, and that sigma, the standard deviation, is 2.75. According to the empirical rule, what percentage of these funds are expected to be within one standard deviation of the mean? And according to the empirical rule, what percentage of these funds are expected to be within two standard deviations of the mean? Well, according to the empirical rule, for any normal distribution, about 68% of the results will fall between 1%, one standard deviation from the mean, 95% will fall within two standard deviations, and 99 will fall between three standard deviations. So to answer this question, for 68 standard deviations, for one standard deviation, the answer is 68%. This is a percent sign, sorry. And then for two standard deviations, it's 95%. So those answers are pretty simple. So now let's get into the Chebyshevs rule. What percentage of these funds are expected to be within one, two, or three standard deviations of the mean? Well, according to Chebyshevs, this allows you to extend this idea to any distribution, even if that distribution isn't normal. The theorem states that for a population or sample, the proportion of observations is no less than 1 minus 1 over k squared. You can only use Chebyshevs theorem to get results for standard deviations over 1. Standard deviations over 1. So that's key. So if we go back to the problem where it says what percentage of these funds are expected to be within one standard deviation, we cannot calculate that because Chebyshevs is only used for results for standard deviations over 1. If we go ahead and attempt to solve it, what's going to happen is you're going to plug 1 back in for k. This is the formula. When you plug 1 back in for k, you get 1 minus 1 over 1 squared. 1 squared is just 1. 1 over 1 is 1. So 1 minus 1 is 0. So as you can see, you cannot get an answer for that. There's no percentage. Okay? So if we try for k is equal to 2, it'll be 1 minus 1 over 2 squared. 2 squared is 4, so you have 1 over 4. 1 over 4 is just 0.25, and when you subtract that from 1, you get 0.75. So for two standard deviations with the Chebyshevs, you expect 75% of your data to fall. When you have k is equal to 3, it'll be 1 minus 1 over 3 squared. 3 squared is just 9. When you divide out 1 over 9, you get a bunch of 1s. So when you subtract that from 1, you get 0.111111. When you subtract that from 1, you get you're going to get a bunch of 8s, 0.88888. You can round this to 0.8889. So you, with the Chebyshevs theorem, for k is equal to 3, when you're going out 3 standard deviations, you expect 88.89% of your data to fall. Okay. According to the Chebyshevs rule, at least 93.75% of these funds are expected to have 1-year total returns between what two amounts? So we need to figure out how many standard deviations are we going out, so that 93.75% of these funds fall between these values. We don't know the standard deviations, but we can calculate it. So I'm going to take the formula 1 minus 1 over k squared, and I'm going to set it equal to 0.9375. All I did was change the percent to a decimal. And then I'm going to solve for k squared to see how many standard deviations we're going out. So the first thing I'm going to do, let me go to another board so I have more room. I'll rewrite it over here. So the first thing I'm going to do is I'm going to subtract 1 from both sides. I get negative 1 over k squared is equal to negative 0.0625. You can put this all over 1 because what's going to happen is I'm going to cross multiply. My goal here is to solve for k. So when I cross multiply, I get negative 0.0625 k squared is equal to negative 1. The next thing I'm going to do is I'm going to divide both sides by negative 0.0625. You got to be careful with your signs. Remember the rules. A negative over a negative makes this a positive. So what happens is these cancel out. You're left with k squared, and you're going to have a positive 1 over 0.0625. When you divide 1 over 0.0625, you end up with 16. To get k by itself, you're going to take the square root of both sides, so you get k is equal to 4. So you went out 4 standard deviations. So 93.75% of your data will fall within 4 standard deviations. So now that we know what the standard deviation is, let's go back to the problem. Where did it go? So if we go back here, well, no, this is not the screen I want. Just a second. I want to go back to the original problem. We know that the mean is 8.2, and we know that the standard deviation is 2.75. We know we went out 4 standard deviations. So what I'm going to do is I'm going to plug in the mean, and I'm going to plug in the standard deviation. When I multiply 4 times 2.75, I end up with 11. So what you have to do is you need to subtract 11 from 8.2, and you need to add 11 to 8.2. So I end up with an answer. When I subtract it off, I'm going to go back to the question. When I subtracted it off, I ended up with negative 2.8, and when I added it, I got 19.92. Sorry, 19.2. So according to Chebyshevs rule, at least 93.75% of these funds are expected to fall between negative 2.8 and 19.2. Alright, I hope this helps.